John Deere offers a wide range of advanced tailor-made irrigation solutions to growers around the world. Every irrigation system begins with a water source. From there, the water is transported through a pipe to the pumping station, which builds the pressure in the system. The filtration system ensures that the water quality meets the crop needs. The fertilizing system provides nutrients to the plants, and the controller manages the irrigation process. Once the control head is installed, it can be connected to the main line, which in turn delivers water to the different field sections. Each section has its own control head with a dedicated control valve and a filter. A hose or a manifold is deployed at the head of the section. The drip lines are connected to the hose or manifold and laid out along the crop rows. From the water source to the drip lines, the system is now ready for operation. When the pump is turned on, it draws the water into the pipe through the suction filter in the reservoir. The pump provides energy to the water, enabling proper operation of the system. The filtration system blocks dirt particles, promoting effective and long-lasting performance. The fertilizer pump provides precise amounts of nutrients required to meet the specific needs of the plant at each stage of growth. The control valve on the main line regulates the water pressure as it moves downstream into the field sections. The valve maintains the required pressure and ensures that each field section receives the correct amount of water. The secondary valve is turned on according to the irrigation plan. The manifold is now filled, carrying the water throughout the field to the pre-installed drip lines. The drip lines produce efficient and uniform flow, delivering an equal amount of water to each plant. Supported by effective irrigation, the crop seedlings can now emerge into the light and grow into strong and healthy plants. John Deere products deliver water where and when you need it throughout the irrigation season.
This test is go.
T-minus 50 seconds. T-minus 45.
The rocket motor is now armed.
T-minus 40 seconds. T-minus 30 seconds.
Sounds of a high-speed camera.
T-minus 20 seconds. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire.
We have ignition of the Ares 1 first stage 5-segment solid rocket motor.
Plus 10. Plus 20. Plus 30.
Amazing display of power.
Plus 40.
22 million horsepower.
Plus 50. plus 70. Plus 80. Central Support Systems Operator, CO2 quench and water doubling.
Roger, enabled.
The water quench system is now being activated.
Plus 90. Enable accumulator, turn on hydraulic pump.
Accumulator enabled, hydraulic pump is on.
Plus 100. Plus 105. Activate the aft gallery.
Absolute, activate.
Plus 110. Activate the forward gallery.
Approximately 10 seconds more. During the tail off
Plus
here.
120.
Completion of burn, as expected. Now you see moving in from the right in the lower part of your screen the CO2 quench arm. It's like a large CO2 fire extinguisher to put out the fire on the nozzle and the internal components of the rocket motor so the engineers can see the condition that they were exactly at the end of firing. Very important for collecting the data that's necessary. Everything looked normal through the firing. It's approximately 30,000 pounds of CO2 that will be put through that arm into the rocket motor. There you see the beautiful northern Utah sky with a lot of dust. During the test, the flame exited the rocket motor out of the nozzle at about Mach 3, burned for approximately 123 seconds, and the temperature of that flame approached about 4,500 degrees Fahrenheit. This is approximately 2/3 the temperature of the sun's surface. At this temperature, steel does more than melt.